Hi everyone, welcome to the second session on our course with data visualization using Tableau. Before we begin, could you please ping me and confirm if you can see the screen I'm sharing and if you can hear me well? Thanks for confirmation. So let's start with our discussion today. And Shilpa, I just saw your question, so I'll try to answer that somewhere in between the session. I hope that's okay, Shilpa? All right. So let's start off with our discussion today. And today we are going to talk about basic visualization design, including some concepts behind how we should create or think about, going for a particular visualization. So before we go ahead with our discussion, let's quickly recap what all the things we have learned in our previous session, which was yesterday. We learned about business intelligence, about that domain, what are the benefits offered by business intelligence tools, and the different kind of BI tools available in market, and out of them, why Tableau is so important. We learned some job trends about Tableau, and we saw that Tableau is sort of, the demand for Tableau is getting higher and higher, and it's leading the path when it comes to different BI tools. So it's one of the leaders when it comes to career opportunities and industry adoption. Then we had an introduction of Tableau, and we compared different products which are available from this company. So we had Tableau Desktop, which is the flagship product. Then we have Tableau Server, which is used for publishing our reports. Both of them are paid products. And when it comes to free products from Tableau for learning purpose, we have Tableau Public. And if we want to share our work with others for free, if we have very limited number of users, we do not want to go with Tableau Server. In that case, we can ask them to install Tableau Reader, and then we can transfer our file to the end user, and they can view the file using Tableau Reader. So these are different products which Tableau has to offer. Then we compared Excel and Tableau together. So we imported some data in Excel. We tried to use pivot table functionality of Excel to summarize that data. And we saw that Tableau has some really good visualization capabilities as compared to trivial reporting tools. Then we installed Tableau. We imported that data in Tableau, which we used in Excel. And then we, while exploring Tableau's interface, we created those visualization, those geospatial maps, and then we saved them onto our Tableau public profile. So this was our discussion yesterday. Today, we are going to learn about following topics. So we'll have an introduction of visual analytics, and then we'll learn about some common kind of visualization, including scatter plot, histogram, bar graph, box plot, pie chart, and line graph, and when to use what kind of visualization. Also, that is something we are going to discuss today conceptually. So let's start off. Visual analysis. Let me give you a formal introduction of what is visual analytics. So visual analytics is a form of inquiry in which the data, we use some data, and the data helps us take out insight, which is used to solving a problem. So basically in visual analytics, what we do is we try to find information by creating graphs and charts. Now, visual analytics helps us identify trend, patterns, relationship in data, which is otherwise very difficult to find just by looking at tabular data or raw data. So if we chart that data, if we create graphs from the data, the trends, patterns, relationship in data gets highlighted, and it gets easier for us to find insight from the huge volume of data. Especially useful and helpful if we are dealing with extremely large amount of data or a complex data set. So for example, big data analysis, data mining, where a very high degree of monitoring and interaction is required. In those cases particularly, visual analysis is something which you cannot live without. You have to use visual analysis. So let's get into detail of visual analysis, and let's learn about different kind of visualization which we can create, and under what circumstances we should go for a particular visualization. So first visualization we're going to talk about is scatter plot. So my question to you all is, have you seen a scatter plot? Do you know what a scatter plot is? Have you ever created a scatter plot? What do you think is the use of a scatter plot? Or anyone who has no idea at all what a scatter plot is? Okay, so I can see many of you do not have any idea what a scatter plot is. So let me go ahead and introduce you to scatter plots. But before I do that, let me talk about three different kind of data categorization. So talking from a perspective of categorizing any kind of data, there are three broad categories in which you can put data into. So let's say you have a column of data. Let's say you're working on a data set and it has 10 different columns. So each of the column of data may fall under three different categories: nominal, ordinal, and ratio. Ever heard of these terms before? Nominal, ordinal, ratio. Anyone who would like to share their understanding of what these data types are? Okay, so let me explain to you. Nominal data is data which cannot be compared to each other. So if you have a column of data which you cannot compare to each other, you cannot tell one is better than other. It cannot be compared. So if you cannot compare the data, then it is called as nominal. Ordinal data is something which you can put in an order. So you can compare the data, but you cannot find the difference between it, or cannot find the ratio between it. I'll give you some examples shortly. Ratio data is something which you can compare, which you can find a difference between, which you can find a ratio between. So all these operations are possible with ratio data. Some example of nominal data. I'm going to quote the same example of HR data. Let's say if we are dealing with HR data, we're trying to visualize, analyze HR data of a company. So name of an employee. So we might be having different names, different employees have different names. Can you compare two names and say one is better than other? You cannot do that. Similarly, gender, male, female, can you say females are better than male or vice versa? You cannot do that, right? So these kind of data sets are nominal. You cannot compare them. Then we have ordinal data. Ordinal data is something which you can put in order, but you cannot define the difference between them. You cannot find the difference between them. So for example, performance rating. Now you know a high performer and a average performer and a poor performer. So high performer have performed better. Medium performers, average performers have performed as expected, and poor performers were not able to deliver as per their expectation, whatever expectations we had from them. Fair enough, we can put them in order. If you are going to select a candidate from a different team just by looking at his performance rating, you can make a choice. But let's say we have two high performers. Can you say that both of them are absolutely equal? Both of them have got high performance rating. Can you say that both of them are exactly equal to each other? You cannot tell that, right? You cannot find difference between them. One high performer might be better than the second high performer. If we have two average performers, it's not necessary that both of them are absolutely equal. Which one is better? You cannot tell them just by looking at their performance rating. Of course, between high, medium, and low, you can categorize, but between two high, even between high and medium, you cannot find the difference. Okay, you cannot say that high performers have performed twice as better as medium performers. You cannot say that. So there will be, let's say, one high performer and two medium performer. The gap between high performer and the first medium performer might be less. The gap between high performer and the second medium performer might be more. So you cannot compare difference between them. That is ordinal data. And then we have ratio data. Ratio data is like age, salary. Okay, you can compare them and you can also find difference between them, ratio between them. If an employee is earning twice of a second employee, you can determine that conclusively. You can calculate that. You can say for sure that the first employee is getting twice salary of second employee. You can calculate the difference between them. Similar is the case for age. You can tell this first employee is 10 years older than the second employee. Okay, so this is nominal, ordinal, and ratio data. I hope you understood that. Now, could you please ping me your answer? I'm going to present to you certain, column names, some data. could you categorize them as nominal, ordinal, or ratio? Okay, just ping me if the data which I'm going to present to you is that nominal, ordinal, or ratio. Okay, so students in a classroom, they have been ranked. So a particular student, he stood first in the class. There was a student who stood second in the class, and there was like a person who took the third position. So I have provided student ID, and next to that I have provided his rank, which he held in the class. What kind of data it is? Is it nominal, ordinal, or ratio? Okay, got answer from Dinesh, Vineet, Virendra, Shilpa. So I'm talking about rank, yeah. Okay. So rank of the student will be ordinal, right? So there's a student who stood first, probably he got 98% marks. There's a student who stood second, he got 96% marks, and the student who stood third, he got 90% marks. So between first and second, the difference is only 2%, but between second and third, the difference is 6%. So you cannot say that, okay, because the difference between first and second was 2%, so the third person, he got 94%. You cannot say that, okay? And this is just not ordinal data. How about the department in which a particular employee is working? We have employee name, and next to that we have his department name. So department name, what kind of data that is? That's nominal data, absolutely correct. And let's say we have sales of a company, how much sale the company was able to generate in last one quarter. Yep, that's ratio. Okay, so I think you have understood the difference between nominal, ordinal, and ratio. So with that context in mind, let's try to understand when to use what kind of visualization. Scatter plot is a graph which shows relationship between two set of data. If you want to investigate if there's a relationship between two set of data, then we use scatter plot. But what are these two sets of data we are talking about? These two sets of data are ratio data. If we have two ratio columns and we want to investigate the relationship between them, if there's a relationship between them or not, then we create a scatter plot. Let's consider this example. So there is an ice cream seller and he's selling ice cream, and he has a feeling that based on temperature on a given day, the ice cream sales are impacted. So what he does is he collects data for 12 days, last 12 days, 12 o'clock in the afternoon, what was the temperature and how much ice cream sales he was able to generate. So he has a feeling that there's a relationship between them. Both of them are ratio data. Okay, they can be compared between, you can make comparison. So a particular day is hotter than the first day. So this day was hotter than this one, and difference also you can calculate. So is the case for ice cream sales. So when you have two ratio data, you want to find relationship between them, we use a scatter plot. So the shopkeeper, he collects this data and then he visualizes this data using a scatter plot. This is how a scatter plot looks like. So on one axis we have one variable, on the other axis we have the second variable, and then we plot the points where these variables intersect. So for example, day number 1, temperature 14.2 degrees, sales was 215. So 14.2, sales was 215, we put a dot here, and similarly for each of the data point we keep on putting dots, and then we are able to visualize that between temperature and ice cream sales there is in fact a relationship. See, if you look at this data at a on an overall level, you see as the temperature is increasing, ice cream sales is also increasing. Temperature is increasing, ice cream sales is also increasing. This is called as a positive relationship. Okay, so we say there's a positive relationship between these two data set. All right, so let's try to create a scatter plot, and let's try to see how within Tableau we can create a scatter plot. So we are going to use pricing.csv. This data set is already available on share folder. I hope you have the path of share folder. Just in case if you don't, let me share that with you once again. So for those of you who do not have path of the share folder, on the chat window, I'm going to share the path with you all. So through the chat window, you can just follow the link and you can access this particular file, pricing.csv. So let me explain this file a little bit to you. This file contains data for different cars. So this is our first car. The make is Alfa Romeo. Some of the cars are Audi. Some of the cars have BMW, Chevrolet. What is the fuel type? What is the aspiration? How many doors the car has? What is the body style? And there are several other features of the car which we have recorded in this data set. How many cars we have this data for? We have this data for 195 different cars. Okay. What we want to investigate is, let's say if we want to buy a powerful car. I want to buy a powerful car. Power of the car is determined by horsepower. So if the car is having more horsepower, it means the car is more powerful. Okay, it will be able to run at a higher speed. It will have more pickup. I'm no expert in automobile technicalities, but from a layman's perspective, that's what I'm telling. So more the horsepower, the more powerful the car is. So you want to buy a powerful car, but you are also very cognizant, very careful about the pricing of the car. So you have a feeling that horsepower influences the price. So you draw a scatter plot, which will look something like this after we have drawn it on Tableau. Could you tell if there is a relationship between HP and price? And if there is a relationship, what nature is it of? Is it positive or is it negative? So what is positive relationship and what is negative relationship? Positive relationship is when both the variables move in the same direction. If one increases, the other also increases. If one decreases, the other also decreases. If that is happening, then we say there is a positive relationship. Negative relationship is when one variable increases, the other decreases. Okay, so let me show you this one here. I'm sorry. This is a positive relationship. Temperature increasing, sales increasing. This one, horsepower increasing, what is happening to price? Compare two cars. This is first car, let's say, and this is second car. Between first car and second car, horsepower has increased. What has happened to price? It has also increased. Between this car and this car, horsepower increased, price also increased. Of course, it's not a perfect relationship, but in general, data is moving upwards. So what kind of relationship is this? It's a positive relationship, right? And there is not a very solid relationship as such, but there is some relationship. You can see when horsepower is increasing, point at any of the circle here, horsepower increases, price also increases. In general, this data is moving upwards. On the contrary, here is a data which has negative relationship between horsepower and mileage. As the horsepower increases, the mileage of the car decreases. Okay, so this is a negative relationship. See, these cars, they have higher mileage and lower horsepower. These cars, they have higher horsepower and lower mileage. So as the HP increases, mileage decreases. This is an example of negative relationship. Okay, so I hope that's clear. Scatter plot and the relationship, how to judge the relationship between two ratio variables. So let's start working on this data now. Let's import this data. This is a CSV file. So we go to the text file area. We open up Tableau. We go to the text file section and then we import pricing.csv within Tableau. Okay, so here now we can preview the data. We have different cars, Their make, fuel type, aspiration, number of doors, and all such details are mentioned here. Now our next step will be to go to this worksheet. All these things we have learned yesterday. And now we are on a working canvas. Now we can create a scatter plot. So I'll just take a pause here, let you all catch up. Once you have imported your data within Tableau, please let me know so we can move forward with our discussion. Once you are able to see the screen which I'm sharing, you are at the same screen, please do let me know. Okay. So Dinesh, let me just look at your question. So let me just back up a little bit and import this data from scratch. And Dinesh, please follow the screen, and probably that will help you solve the problem. So start a new instance of Tableau. If let's say if your file is already open, your previous dashboard is already open, close that first. Or maybe what you can do is, if you want to keep that dashboard open, no problem at all, go to Start menu and click on this Tableau icon again. In that case, a new instance of Tableau will open up, and then you can import this text file, pricing.csv. Please try that. If that doesn't solve the problem, then I can make you the presenter and help you step by step. And once, if this problem is solved, Dinesh, please let me know. Okay, done. Perfect. So Anand, to answer your question, in real time, who gives this data for work on it? So are you talking about from an organization perspective? How will you get the data if you are working on a Tableau based project? Okay, so let's say if you are working in an organization in the BI team, you will have access to the data. So mostly what happens is, those people who relevant people are provided access to the data. So you will probably connect to a database, or if let's say if you have a data access to a data mart, you can export the data in CSV format from any of the data marts or a database, and then you can import that within Tableau. You can also make live connections, something which we are going to discuss later on. Does that make sense, Anand? Was I able to answer your question? So based on your role, you will be provide access to the data. Okay. So now we are on a work canvas and we are going to create a scatter plot which will show us the relationship between horsepower and price. So the steps are as follows. On a scatter plot, look at all the components we have. We have HP, we have price. So of course we need these two columns, but we have one circle for each car. See, we have so many different circles. So we'd also need the car identifier. So these three things we are going to require. Okay. So of course we need miles per gallon. So price and HP. So let's take price. Let's take HP. If we consider only these two variables and we go ahead and create a scatter plot, let's say, okay, let's say we create a scatter plot just by taking these two variables, then we will get just one circle here. Why? Because Tableau is going to sum up the price for each of the car and sum up the horsepower, and eventually we'll have one sum of price, one sum of power, and wherever they are intersecting, Tableau is going to draw a circle there. And this is not what we wanted. We wanted to investigate relationship between price and horsepower. So we need one circle for each of the car. So a car is identified by the car ID. So drag car ID, throw it in the detail section. That is one way. There are several different ways of creating a scatter plot. Here we have our first scatter plot is ready now. This is one way. Another way, let me show you. Take car ID and throw it right on the canvas. This is another way of creating a scatter plot. Third way, which is the easiest, is while creating a scatter plot, select car ID, horsepower, and price. All three are required. And then if you create a scatter plot, then all the circles will be shown. So quick check. Just try to create this scatter plot and please ping me and confirm to me once you were able to do so. If you are facing any difficulty, please let me know. So today we are going to have many quizzes. So I'll keep you busy. You always have to be, agile and keep working on creating visualizations. So very, very small visualizations I'm going to create, and then you have to replicate them in form of quizzes. Okay, so you have created the scatter plot. Nice. Now, you see the scatter plot which I have created. Here, in this case, HP is lying on x-axis and price is lying on y-axis. If you want to flip the axes, okay, if you want to achieve that effect, see here, price is lying on x-axis and horsepower is lying on y-axis. It's the opposite of what I have drawn here. What if I want to flip the axis, put price on y-axis and HP on x-axis? In that case, there is this small icon on the toolbar. It's if you hover your mouse, it'll say swap. So you click here and your x-axis will become your y-axis. Your y-axis will become your x-axis. Okay, so let me repeat the step. Let's say if you want to flip the axes, you go here on the toolbar, there is a small button, it says swap, you click that one and your x-axis will become your y-axis. Y-axis will get converted into x-axis. This axis will be swapped. Anand, were you able to create the following, this particular scatter plot? Okay, do you need any help? Should I make you the presenter? I can help you step by step if you want to. All right, so let's do that. I'm going to pass on the ball to you, Anand, and please share your screen. So I've made you the presenter. Okay, so now we can see your screen. So the first thing you need to do is hold down your control key, click on ID you have already selected, that's good. Now select horsepower by clicking the control key. Just hold down the control key. You select price by holding down the control key. All these three you need to select simultaneously. HP, price and car ID. Yeah. Now go to show me. That show me button on the right hand side. Okay, and select that scatter plot, not that one, that's a circular chart. Okay, so on the left hand side at the bottom there is a scatter plot option. On the left hand side, yeah, the left hand side, yes, right here, yes, this one. So this is a scatter plot. Please click this one. Okay, here is your scatter plot. Now as you can see, price is coming on x-axis and horsepower is coming on y-axis. So if you want to swap that, on the toolbar you see a small icon that's next to that sorting button on the toolbar. Yeah, this one. So you click here and see the axis has been swapped. All right, so good job there. Now I'm going to take back the screen control and present a small quiz to you all. Before I go ahead, could you help me answer the following question? If I am planning to buy a car with power of more than 170 HP, okay, so 170 HP will be around here, somewhere around here. Which car should I choose? Which car should I ignore? Considering that I also give equal preference to pricing of the car. I do not want to go for an expensive car. So I'd say I can go for this car ID 99, or I can go for this car, which is car ID 69. Either of these cars, they do not have very high price, and they have sufficient power. They have power more than 170 HP. Does that make sense? Car ID 69, of course, and car ID 99. Either of them will work. So there's a small minor difference between the pricing of these cars, but I'm also getting some additional power. So these kind of cars I'm definitely going to avoid. They have very little advantage when it comes to increase in power, but their price is significantly higher. So these two cars can be a perfect choice for me. Okay, now could you try to answer the following quiz? Can you create a scatter plot which will show the relationship between mileage and horsepower? Same data set. I want to investigate if I'm going to buy a powerful car, will I get more mileage? Will I get less mileage, or will nothing happen? Actually, it doesn't matter. Dinesh, that's not true actually. So once we go through this entire session, you'll realize that we can use dimensions in axes as well. It's not always going to be in the detail section, but yeah, in some areas, especially the scatter plot, a dimension is going to be in the detail section, but it can also lie in the axes as well. So Vineet, you want to zoom this chart, as in like you want to increase the size of this chart? Okay, so if you want to increase the size of this chart, you can choose this one, this option here. If you click on this drop down on the toolbar, if you see it says standard, if you choose this one, entire view, let's say, so the chart will become bigger, entire view. If you choose to fit height or fit width, then accordingly the chart will change. So Anand, please try to create this scatter plot. If it doesn't work, just let me know. I can help you out with that. Okay. So let's move on to the next category of chart in between. And Anand, please feel free to stop me at any point of time if you need any help with the scatter plot. So moving on to the next category of visualization, we are going to discuss now about histogram. Yeah, Naveen, I'm going to answer that question, but not today, maybe in one of our future sessions. So there are ways through which we can find the information contained within the chart. Okay, so next category of chart is histogram. So what is histogram? I'm sorry, let me just take up this question. Yes, so if you want to figure out if a chart is circle chart or a scatter plot, so if you hover your mouse on the chart, it will actually call out the name of the chart. See here it says circle view, here it says side by side circle, here it says scatter plot. So this is what a scatter plot is actually. And we are going to create modified versions of scatter plot also later on. Right now we are just learning about basic visualization. So we are going to create advanced scatter plots and all later on. But you hover your mouse and Tableau will tell you the name of a particular visualization, a histogram, box and whisker plot. So if you can just, you can look at the name of the chart right here, Gantt chart, bullet graph, okay, line, film, area map, so all these details. Is that what you were asking for? So Naveen, let me do this. Okay, so you are looking at a particular chart built on Tableau and you want to figure out what kind of chart it is. Is that the question? So somebody else has built the chart and you want to figure out what chart category they have used. So in that case, you need to have Tableau developer, and you need to have, you should have access to the TWBX file or TWB file, whatever. And then you can go to design mode of that chart and you can figure out. We'll talk about that when we are going to discuss about dashboard. So that will be in our third week. So in our third week, we're going to talk about dashboards, and that's when you can figure out, after learning about dashboards, you can figure out what chart has been used. Fair enough? Okay. So let's learn about histogram. What is histogram? Histogram is a graphical display of data which use a bar like notation. So we create, bar graph sort of a chart. It looks very similar to a bar graph, but it is used to figure out the distribution of data. Histograms are a great way to show results of continuous data. So in general, ratio data. If you have a ratio data, we can use them to check its spread. So spread of data can be determined using histogram. So like, for example, height, weight, currency, salary, age, all these kind of values if you want to check their spread, we use a histogram. So let's look into this example. Histogram is something which we have actually learned in our high school, and some of us might be using that also, but it's something which generally has been constrained to statisticians for a long time. But in Excel, it's very difficult to create actually a histogram. I'm talking about older version of Excel. Probably in newer version of Excel, there might be some easier way. But in Tableau, creating a histogram is very, very easy. So what is actually a histogram? Let's consider this particular example. Let's say we have an orchard and we have different trees which we have grown in that orchard. We want to understand the height distribution of trees in that orchard. Do we have taller trees? Do we have shorter trees? Or do we have trees somewhere in between, neither very tall nor very short in our orchard? So what we do is we measure the height or whatever, the height will say, yeah, of course. So height of each of the tree, and then we are going to bucket them in something which we call as bin. Okay, so we create bins between of 50 range, and that really depends on your choice. So between 100 to 150, how many trees are there? Between 150 to 200, how many trees are falling? Between 250 to 300, how many trees are falling? And then we draw a bar-like representation. Now this is a histogram. On one axis, we have a ratio data. On another axis, we have count of elements, count of data falling into each of the bucket. These buckets are called as bins. Okay. So now, by looking at this histogram, we can say most of the trees in our orchard are relatively taller. We have very few trees which are extremely short, and most of the trees fall in this range, 250 to 300 range. Okay. So that is the use of a histogram. So with that knowledge, let's try to create a histogram on the same data. So let's say we are a car distributor, we are selling cars, okay, and we have all these different cars, and we want to understand the length distribution of cars. In general, do we have extremely long and extremely short cars, or do we have cars somewhere in between? So we create this histogram, and then we can see that we have very few cars which are extremely short in length and extremely long in length. Most of the cars are somewhere in between. Okay, so this is how histogram helps us. So let's create this histogram. To create a histogram, very few steps are required actually. I want to look at length distribution of cars. So I'm going to select length, and then I will go to show me, and here is a choice to display the histogram. So I'm just going to click here, histogram, and Tableau is going to draw this histogram on screen. So Tableau has automatically determined the bin size to be 5. So number of cars between 140 to 145, number of cars between the length of 145 to 150, and so on and so forth. Okay. Now, if we want to change that bin, here is our option. So when we create a histogram, Tableau is automatically going to create a new variable for us, which is a bin variable. So we can right click and edit this. Please follow the screen which I'm sharing, otherwise you're going to miss out on how to edit the bin. Okay, so when we create a histogram, Tableau is automatically going to create a bin. So we can edit that bin size and make it more customized. So let's say I want the bin size to be 10. So I enter that bin size and my histogram will change accordingly. So here is my new histogram. It shows that we have extremely few cars in the extremely long and extremely short category, and most of the cars are lying somewhere in between. And then if we want to show labels, we can show labels here. So how many cars we are talking about. So I go to label section and click on this checkbox. All right, I'm back, and sorry for that pause. So quick check. Are you facing any difficulty in creating this histogram? I've got confirmation from Vineet. Vineet was able to create this histogram. How about others? Just let me know if you need any help with editing the bin size, anything at all. Okay. So I've got confirmation from all of you. That's great. So it's really easy to create a histogram. Could you try to create the following histogram? So now we are trying to look at height of the cars. Instead of length, we are trying to look at height of different cars. This histogram is a bit different from what we had previously. What this histogram is telling us is we have extremely few cars which are very short in height, but we have some good number of cars with that extra height, So there are a lot of tall people, they prefer to drive taller cars. So in those cases, for those kind of customers, we do have some good amount of options available. Here, as you can see, we have only one car which is extremely small, extremely short, and 7 cars which are like shorter. But we have 26 and 10 cars which are very tall. So histogram does give us some insight of the data and helps us understand our data better. So please try to create this histogram, edit the bin size as I've shown in the figure, and also try to show the labels on top of the bar. Okay, so Dinesh, here is the thing. See, the height of the bar is determined by excuse me, is determined by count of cars, and these categories, they are determined by the bin. So if you want to have, like, let's say different colors, let's try to throw bin on the color section. Okay, so this is actually continuous data, and because of that you are able to see the same color for each of the bin. So what you can do is, if you take number of records and throw that in the color section, then you will be able to see different colors. So basically, I was going to talk about number of records, but since you have asked that question, let me talk about it right now. So number of records is a field which is auto-generated by Tableau. Whenever you are going to import any kind of data in Tableau, this field will be generated. Number of record will tell you how many rows we are talking about. Now, in this histogram, the center point, which has the maximum height, this has most number of records, hence a taller bar. If you take number of records and throw it in the color, you will see those bars which have relatively less number of cars falling into them are lighter in shade, and as the number of car in a particular category increases, the shade of the bar gets darker. Okay. So Dinesh, were you able to find a similar solution by yourself? Nice. Okay. So with Tableau, I have already told you it always is making some consistent changes, upgrades in its visualization. So in older version of Tableau, if you are using version 9.3 or some other version, you will be able to see chart which looks like this. So there'll be a number right beneath the chart, and also there'll be some gap between the bars. But in newer version of Tableau, which is version 10, Tableau is going to stick the bars together. Is there anyone who's using version 9.3? Anyone using version 9.3? I remember someone told me yesterday. Okay, so it seems nobody is using version 9.3 as of now. Okay, but if you are going to use this, create a histogram in version 9.3, the bars will be a bit far off from each other. So you can just, set it manually and increase the bar size. You can do that. It's not looking very good as such, so it's better to keep it fixed. So Tableau version 10 has some upgrades. All right, so moving on. Now we have learned about scatter plot and histograms. Let's learn about bar graph now. We actually created some bar graphs yesterday, but let's learn when to use a bar graph. So bar graph, which is also called as a bar chart. Before I go into those details, let me ask you, based on your general understanding, if I'm going to draw a histogram of employee salary, so we have many employees working in an organization. Let's say 10,000 employees are working in a particular organization, and I'm going to create a histogram of their salary. How do you think the histogram will look like? Is it going to look like this, where we have biggest bar in the center, and then smaller bars at the extreme end? This is called as a normal distribution, by the way, a bell-shaped curve. Are we going to have a chart like this, a histogram like this? Or are we going to have a histogram which will look like this, where we have taller bars on the extreme end and shorter bar on this end? Or our histogram is going to look like this, where we have taller bars here and shorter bars on the right hand side. These are called as skewed data. These two are called as skewed data. This is normal data distribution, a very important thing in Six Sigma and statistics. So if you are going to create a histogram where you are going to plot salary of employees and how many employees are earning that salary, so the height of the bar will depend on number of people earning a particular bracket of salary. Here on the x-axis, we are going to have brackets of salary. Employees earning between 10,000 to 20,000, employees earning between 20 to 30, 30 to 40, 40 to 50, beyond 1 lakh, beyond 5 lakh, beyond 1 crore, maybe. So if you are going to draw a histogram which will show number of employees and their salary group, are you going to get type A histogram, type B histogram, or type C histogram? Based on your general knowledge, what do you think? Okay, I've got response from Mr. Chaudhary. How about others? Got response from Shilpa, Dinesh, Vineet. Okay, some of you have got it correctly. We can expect to see type C histogram, okay, because most of the employees in an organization will be associate level, senior associate level. If it's an IT organization, there'll be software engineers, senior software engineers and all. They might be earning in a lower bracket of salary. Then we will have assistant vice president, senior managers, vice president, directors and all. Very few of them, but earning extremely high salary. Okay, so this size of the bar is going to decrease. The n number of people falling in that category will be less, but the bar is going to, the entire graph is going to get stretched towards extreme end. Why? Because there'll be CEO and senior vice presidents who will be earning extremely high. Do you agree to that? So this is how we can expect to see a graph. Okay, so histogram actually clarifies, visualize these kind of situation to us. It helps us understand the data better. Now next category of chart is bar graph. Bar graph we have already seen yesterday. It is again use bar like representation to display data, and bars can be of different height. Bar graph is used when we have categorical data and we want to compare two categories together. So let's say let's consider this following example. Let's say we are going to survey different people. We are going to survey 145 different people and we are going to ask them what is their favorite fruit. We went to first person, asked him, what is your favorite fruit? He said banana. Second person we went to, asked what is the favorite fruit? He said blueberry. We keep on noting how many people like blueberry, how many people like apple, oranges and all. And then finally we plot it in a bar graph format. And then bar graph tells us that blueberry is the favorite fruit and grapes is the least favorite amongst all these different fruits. Now histogram is used when you have continuous data and you want to analyze its distribution. Is most of the data lying on the left hand side, most of the data lying on the right hand side? Is the data normally distributed? Do we have younger employees? Do we have older employees? Or do we have mostly middle-aged employees, extremely few which are extremely young, extremely few which are extremely old? Maybe if you want to do retirement planning, so a lot of people are going to retire. Do you want to do workforce planning? A histogram can be a good choice. But if you have categories, how many people are working in a particular department? So we have HR, finance, marketing. How many people are working in HR? How many people are working in marketing? How many people are working in IT? We use a bar graph. When we have categorical data, you want to compare categories, we use bar graph. When you want to check the distribution of a continuous data, a ratio data, we use a histogram. I hope that difference is clear. And in histogram, the bars tend to stick to one another. So if you look at this histogram which Tableau draw for us, these bars are sticking to one another. In a normal bar graph, the bars have some space in between. So that way we can demarcate between histogram and a bar graph. Okay, so let's actually create a bar graph. We are going to create the following bar graph. We want to figure out of all the cars we are selling, what is the most common body style. So we are selling some convertibles, we are selling some hard tops, some hatchback, sedan, wagon. So these are the different body styles of the cars we are selling. Which is the most common body style we want to find out. So we need a bar graph. Why? Because we have categorical data which we want to compare. So let's open up Tableau, insert a new sheet by clicking on this icon, and we want to compare body type. Here is body style. Okay, body style is what we want to compare. So select body style and we want to see how many cars are falling under which particular body style. So we hold down the control key and we select number of records. So we have body style and number of records. Then we go to show me and create a bar graph. So I'll allow you all some time. Please create a bar graph quickly, showcasing different body styles and the number of cars falling under each body style. Once you have a similar representation, please let me know. All right, got confirmation from Virendra, from Vineet, Shilpa, Dinesh, Mr. Chaudhary. Awesome. Thank you. Thanks, Anand. Okay, now this is a horizontal bar chart. What if we want to show it in a vertical format? We want the bars to stand vertically up rather than lying flat horizontally. Again, we can take help of the same button, swap button. Click on the swap button and the axes will change. Now we have a horizontal bar graph. Okay, if you take your mouse here at this juncture, you will see the icon changing. You can drag and increase the width of your bar plot if you want to. How to color code each of the bars separately? You know that already. Each of the bars represent a different body style. So drag body style, throw it in the color. Now we have different colors for each of the body style. You want to show how many cars we are talking about on top of each bar? Go ahead and display the labels. This way our entire bar chart is ready now. Got confirmation from almost every one of you. Thank you. So I'm assuming nobody is having any difficulty in creating this bar graph. Awesome. Thanks for confirming that. Now, let me just briefly talk about the labels which we have displayed here. Okay. So one way to display the labels is click on this label option and click on this checkbox. So this is how you can toggle the labels on and off. This is one way. Another way is you can just take number of records. Okay. So we have each of the bar size is being represented by number of records. So take number of records and you can throw it in the label section. That's another way of showing labels. Between these two methods, the preferred method is the second one, where we take number of records and throw it here. Why is it a preferred method? I will talk about that shortly. Okay. So in the meanwhile, could you try to answer the following quiz? Please take a screenshot of this quiz and keep it aside. Do not try to answer it immediately. There are some other quizzes which I'm going to showcase to you. Please take a screenshot, keep it aside, ping me and confirm, and then I will present the next quiz to you. Okay, done. Thanks for confirming that. Here is the second problem. The second quiz. Could you take a screenshot of this as well? And please ping and confirm to me once you have taken the screenshot. All right, I've got confirmation from Dinesh, Vineet, Virendra. Mr. Chaudhary, you have completed the first one, working on the second one. Anand, how about you? Were you able to answer any of the quizzes? Shilpa? Naveen, how about you? Were you able to create both the visualization, both the charts? Okay, so let me show you how can you format the labels. If you want to get this label formatting right, you know, this dollar symbol and the K symbol, something which we discussed. So in this case, let's try to compare the prices of different body style. Which particular body style is going to be more expensive to purchase? So we need to visualize price and the body style. So go to show me, choose this bar chart. This is a simple bar chart where we have different body styles and their total price. So we are interested to compare their average price. Why are we interested to compare average price? Why not total price? Because total price can be influenced by number of records. So if we have, let's say, more number of cars which fall in the sedan category, then obviously the bar size for sedan is going to be higher. Not because sedan is more expensive, but because we have more number of cars in sedan category. So it's better to compare the average value. So if we compare the average price of all these different cars, we can see that convertible and hard tops, they are more expensive. If you want to display the labels on screen, you take price and throw that on label. This way, we'll be able to see labels on top of screen. But what are these labels? See, the label for sedan is very high. It's $1 million, approximately 1.3 million. The label for hard top is relatively less as compared to sedan. Why is that so? Reason is the labels are showing us sum of price, if you see here. Whereas the bar height is being determined by average price. Okay. So we need to convert the label as well. So instead of showing sum of price as the label, show average price as the label. Now the label and the bar size are in sync with each other. So the taller the bar, more is the value of the label. If we want to format the label to show it in dollar format, right click. We want to change the label style, right? So this is the component responsible for label. Just compare the icon, and this is the component responsible for label. Right click, go to format, and in the number section, in the default area, choose a currency format if you want to. So show the currency in dollar format, and the unit can be K if you want to keep that unit. If you want to reduce the number of decimal places, you can do that as well. So here is the label format. Shilpa, were you able to get all the steps? If you want, I can repeat them for you once again. Got it? Okay. And of course, color coding the bars so that each body style has a different color is easy. You just need to take body style, throw it in the color. So each body style will now have a different color. Okay. So if you want to create this chart, you need to take body style and their average price, create a bar graph and make it vertical. Then make sure you are comparing price at an average level, not at a sum total level, but at an average level. You want to display the labels. One way is go to the label section and display it right here. This is the non-preferred way. We shouldn't do it this way as much as possible. We should take price, throw it in the label section. This will give us sum of price. By default, Tableau takes sum every time we use it, any particular number. So we need to convert the labels also. We need to make sure labels are also being displayed in average format. And then we right click and change the format of this average price. Right click and choose this format option. A new window will open up on the left hand side. In the top section, go to the numbers area and choose custom currency with a dollar symbol. The unit can be K, and you can decrease the number of decimal places if you want to. And then you can color code each bar differently. How? By making use of this body style. So each body style has a different bar. You want different colors for each of the bar. Take body style, throw it in the color. This way we are telling Tableau that I want to color code my bars by body style. So each body style will have a separate color. Okay, so the first quiz is done. How about the second one? I can see many of you were able to answer the second quiz. Is there anyone who needs my help to answer the following quiz, or was everyone able to do it themselves? So here, there's one thing which we need to take care of. We need to use number of records. So apart from drive wheels, we need to use number of records to create this bar chart. And then we can simply display the labels. Awesome. So everyone was able to create all the visualizations. So let's move ahead and let's discuss about box plot. Now this one is a bit complex to understand, but I'll try my best to explain it as much as possible. And it also requires a level of, some level of understanding of statistical terms. I'm going to pass on an article to you after this session, which will help you understand those terms better. So what is a box plot? I'm pretty sure if you have not really worked on a scatter plot before, box plot is like of a different level altogether. So I'm quite sure no one has used a box plot ever. Is there anyone who has used a box plot ever? Okay, no one. All right, so a box plot traditionally has been used mostly by statisticians, but tools like Tableau provide ability for general users also to create a box plot. So what is a box plot? Box plot is also called as a box and whisker plot. Now this is very similar to a histogram. The usage of a box plot is very similar to a histogram. Histogram, what is the use of histogram? To see the distribution of data, the distribution of a ratio variable, a ratio data. Similarly, box plot is also used to see the distribution of a ratio data. So why do we need a histogram at all? Between histogram and box plot, why do we need two separate visualization? What are the advantages of a box plot? We already have histogram. If we want to look at distribution of a ratio variable, we can always use a histogram. Why to use a box plot? Box plot serves the following two uses. First of all, it is a very useful tool to identify outliers. For outlier detection, box plot is an ideal tool. And then it is also used for significance test. Now, what is an outlier and what is significance test? And also this is a very common interview question. So just a hint for you all, if you're going to sit in an analytical interview, there is a good likelihood they will ask you, I want to identify outliers. How can I do that? If you want to identify outliers, the answer to that question is I can create a box plot and that will help me identify the outliers. So outliers are extreme value which do not gel with your normal data. So for example, coming back to the same scenario, we are looking at HR data. We have a bunch of employees working in an organization and we are trying to analyze their salary. There'll be one outlier in this data. Who will that be? No prize for any guesses, correct guesses, but I think you know the answer. If we are trying to analyze salary of all the employees working in an organization, there'll be one person who will be a clear outlier, whose salary will be far beyond any other employee. Who will be that person? The CEO, of course. So there was like a study which I was reading about the results of that study. So CEO generally used to earn 30 times more than a normal employee in older times. And then the government decided, government passed on a rule that they should publish, every company should publish the salary of their CEO. And that happened. So as per government norms, every company is bound to publish the salary of their CEO. CEOs started comparing their salaries between each other. And now, it's almost like 100 times of a single employee. So of an average employee, if you take salary of an average employee, CEO is earning almost 100 times more than a normal average employee. So it actually backfired. I don't know. That's kind of a funny situation to be in. Okay, so that is, if you are, let's say, want to identify such people, like, if we have clear outliers, you are visualizing salary, then if you use a box plot is going to point out that CEO person to you, that person who is earning exceptionally more salary as compared to other people. Also, a box plot is used for significance test. So let's see how a box plot looks like. A box plot looks like following. Let's say we are comparing average weight of male and female employees working in a particular organization. So generally, from our general knowledge, we know male people, males have more weight. So in general, this is the box for a particular category. The box will be shifted upwards. Okay, so if a particular category is significantly higher than the second category, then in that case, the box of it, if you draw a box and whisker plot, the box will be shifted a bit upwards. So visually, you'll be able to compare two categories together. Okay, now you see in this particular box plot, we have small dots. If I zoom this chart, you'll be able to see small dots. These are individual female employees. These small dots here, these are individual male employees. There is this one male employee who is exceptionally heavy. Maybe he's like obese or something. Okay, and then we have someone who's really lean and who is actually lighter in weight as compared to almost half the females. Okay, but there are some male employees which are not very heavy, and there are some male employees which are extremely heavy. Okay, but in general, female group is lower than male group. So females tend to have less weight as compared to males. This is what this box plot is showing us. How to interpret a box plot? This is how a typical box plot looks like. So there'll be a box and there'll be a line somewhere in the box. It might be in the center, it might be on one side of the box. That line will tell you the median position. Now, what is median is something which you need to know. Median is an identifier of the middlemost value, the value which is lying. If you sort the data, the value which is lying on the 50th percentile. You understand percentile? If you have heard about GMAT scores or CAT score, you might be aware of percentile. So percentile is a measure of position. Somebody in a CAT examination for IMs, they might have got 99 percentile. It doesn't mean that they have answered 99 questions accurately out of 100. No, it's not 99%. It's 99 percentile. It means 99% of people who appeared for the exam, out of 100 people who appeared for the exam, 99% are behind this person. They have scored less than this person. Okay, we have no idea how much this person has scored and how much others have scored. It's just a matter of position. So when we talk about percentile, median is 50th percentile. Q1, which is the first quartile, lower quartile, that is 25th percentile. Q3, that is 75th percentile. And then this is the lowest position, this is the highest position. If you see this particular box plot, this is the lightest female, this is the heaviest female, this is the female at 25th percentile, this female is at 50th percentile median, this is at 75th percentile, this is the heaviest one. Okay, similar is the case for males. So this is how we interpret a box plot. So medians and first quartile, second quartile are not really important in a box plot. What is more important is there an outlier, and is one particular box very, very low as compared to other, or are they sticking very close to each other? Okay, so let's actually create a box plot. I want to compare the mileage, city mileage of diesel cars and gasoline based cars. I want to see if I purchase a gasoline based car, will I get more mileage? Or if I purchase a diesel based car, will I get more mileage? So I create this box plot in Tableau. How to create a box plot? The step-by-step procedure, we are going to look into that. But I create this box plot. Just observing this box plot, what do you feel? If I buy a diesel car, will I get more mileage? Or if I buy a gasoline car, I will get more mileage. Which car is going to give me more mileage? What is your answer? Higher mileage. Which will give me higher mileage. These are outliers. These 2 points are outliers. So basically, while analyzing data, we should ignore the outliers. Why? Because there'll be just 1 or 2 or 3 outliers. Okay, so analysis is all about generalization. Okay, we want to generalize. We want to understand the deeper behavior of data. Here, these are exceptional cases. This is not reality. Reality is this. Majority is reality. These are exceptional cases. So compare between diesel and gas. Which one is going to more likely to give me higher mileage? Just look at the entire figure. This is one box plot. This is another box plot next to each other. This one is shifted a bit upwards. So diesel will give more mileage. All right. Because this box is shifted a bit upwards, but there is a lot of overlap. If you see, if you compare, there are a lot of cars, even in the gasoline categories, which give good mileage. So there's a lot of overlap. You cannot clearly say that if you buy a diesel car, you will get good mileage. You can get good mileage with gasoline cars also, and you can get bad mileage with diesel cars also. But in general, it's at a higher level. At times, you will get box which are totally separate from each other. In this case, for example, okay, this entire box is shifted upwards. This is lying at the bottom. So between four-wheel drive and rear-wheel drive, there is a significant difference. These are statistical terms, and generally there's a test called t-test and ANOVA test, which are used to determine significance difference in statistics. But a box plot can tell if two categories are significantly different or not. Visually, you can examine that using a box plot. Okay, so let's create a box plot. We are going to compare the mileage of diesel versus gasoline based car. So we go to Tableau. We need the mileage, city mileage. We need that. That's what we are going to compare. And we are going to compare it for fuel type, whether the car is using gasoline based fuel or diesel based fuel. So these two categories we are going to require. I hold down my control key and I select both these categories if you want to do that. It's better to create actually a box plot step by step. So it's better to start off with city mileage, and later on we are going to bring in fuel type. So let's start with city mileage. For creating a box plot, we need each individual circle. You see here, each circle is actually representing one car. So car ID is the identifier, car identifier. So you take car ID, you take city mileage, go to show me, and choose this box and whisker plot. So your box and whisker plot will be ready. This is all cars collectively together, irrespective of their fuel type. What is the kind of mileage they are giving? All cars. So please create the following box plot and let me know once you have created this. So a box plot of city mileage of all the cars. Done? Okay. Now we just take this fuel type, we just take this one and drop it in the column section. So essentially what are we telling Tableau? Show us two different columns, one for each fuel type, or maybe n number of columns. If we have 10 different fuel types, it will show 10 different columns, one for each of the fuel type. So I drop it here. We have two fuel types, diesel and gas. So Tableau is showing us two separate box plot, one for diesel, one for gasoline. And we can see the box for diesel is a bit upwards. If we compare it with gasoline based cars, see the median is a bit upwards. And on top of that, Tableau has also helped you identify the outliers. These two cars are gasoline based but are giving really good mileage. And then if you want to color code these box plots separately, you can always take the this fuel type and drop it in the color. So you will have separate colors for each of the box plot. Two different box, both of them have different colors. Now consider this. There might be, if you will say, okay, why do I need a box plot to compare the mileage of diesel and gasoline? I'll create a bar chart and I will take average mileage. That will also help me identify that diesel cars are giving better mileage than gasoline cars. Yes, that's true. You can create a bar plot, you can take average mileage and you can compare mileage of diesel and gasoline. That is something you can do. But if there are outliers in your data, that's going to impact. Let's say we have one car which is giving in the gasoline category, which is giving extremely high mileage. So in that case, that's going to drag the average towards itself. And you may face a situation where overall gasoline cars are giving bad mileage, but because of one car, the average is higher. So that may happen. Yeah. So agree with your comment, Dinesh. It will not be able to get the outliers. A quick check. Were you able to get this particular box plot correctly? Were you able to create it on your screen? Comparison of diesel versus gasoline cars. Done. Got confirmation from Virendra, from Dinesh, from Vineet. From Mr. Chaudhary. Shilpa, Anand, how about you? Got confirmation from Shilpa? Got confirmation from Anand. Okay, awesome. Thank you. Now, could you try to answer the following quiz on the right hand side? Could you try to create this box plot which will compare the price of cars based on their drive wheel? So whether the car is four-wheel drive or forward-wheel drive or rear-wheel drive, how much money am I going to incur? Let's say I'm planning to purchase a car and I do not want to buy a very expensive car. So which kind of drive wheel should I opt for? So let me share with you the steps required to create this box plot. It's rather simple. So you take the drive wheel, which is, I'm sorry, where exactly that is, drive wheel. Okay, so here it is, drive wheel. We can take this in the next step. We can start off with car ID and the price of the car, create a box plot, and then drag drive wheel and drop it in the column section. So we'll get 3 separate box plot, one for each drive wheel. Anand, were you able to get that? Okay, perfect. So let's move ahead now. Before we move ahead, I also want to point out this particular observation here. You can see in forward wheel drive and rear wheel drive, this rear wheel drive cars, their price is scattered. At times you have to pay extremely less for rear wheel drive car. At times you have to pay extremely high for rear wheel drive car. But for forward wheel drive, see, all the points are sticking to one another. So forward wheel drive is more consistently priced. Okay, if you're going to purchase a forward wheel drive car, it's very, in all possibility, you are not going to incur extremely high cost or extremely low cost. You will pay as much as other people who are purchasing forward wheel drive, not with rear wheel drive. If you're unlucky, if you get your hands on some car which is extremely expensive because of rear wheel drive, assuming this is the only criteria, you may have to shell out a lot more money than some people. They will get the car at a much cheaper price. So spread of data is also something which we should look at, not only the average value. And so spread of data is also a very, very important factor to consider. If the data has a lot of spread, that's a bad thing. Okay, and spread of the data is checked by factors like standard deviation and range of the data, interquartile range. So all these details you are going to get through the article which I'm going to upload on the share folder. Let me do that right away. So just 1 second. I'm going to upload this document which talks about descriptive statistics. Okay, so in this document you'll be able to see the details around all kind of descriptive statistics. So the field of statistics as such is broken up into 2 sectors. One is descriptive, and the second one is I'm forgetting the name of that, descriptive, and we had, I'm sorry, we had not advanced statistics, we call that inferential statistics. I'm sorry, I recall the term, inferential statistics. So descriptive statistics involves measures like mean, median, mode, standard deviation, range, interquartile range, all these kind of things. Okay, and inferential statistics deals with t-test, ANOVA, regression, these kind of topics. They are advanced analysis topics. So this particular article will tell you about descriptive statistics. It will also talk about different kind of visualization which helps you with descriptive statistics. Visualizations like histogram and box plot. It's a bit at the bottom. So here we have this is histogram, and we do also have information about box plot somewhere at the bottom of the screen. Okay, so this is a box plot, how a box plot is actually drawn if you are going to do that through hand. So I'm going to post this article on the share folder. Please download it and read it in your spare time. It will help you understand the concepts behind these two visualization, histogram and box plot. Okay, so moving ahead with our discussion, now we are going to talk about pie charts. Now pie chart is a common visualization, just like a bar chart, and I'm sure you have already seen pie chart somewhere, maybe in a magazine or in some news channels, or probably you would have used it yourself in Excel or some other tool. So what is a pie chart? Pie chart is used to show the breakup of your entire population, or the the whole 100% group, into its contributing components or categories. And a pie chart should be created only when you have 4 or less categories. It's just a thumb rule. It's a recommendation. It's not something really, which you need to follow as such. So I'm going to create the following pie chart. This pie chart on the right hand side, it's going to tell me out of all the cars which I'm selling, how many cars have 2 doors and how many cars have 4 doors. So this pie chart on the right hand side, let's create this one. I want to look at number of doors and how many cars. So basically number of records is going to tell me how many cars we are talking about. In our data, pricing.csv, we have one row for one car. You might work someday on a data which might have multiple rows for the same element, where one of the element is repeating, the ID field is probably repeating, and you have multiple different measures, maybe captured over a period of time. So how to handle that kind of situation? We are going to require a calculated field for that case, and we are going to learn that later on. In our case, fortunately, we have one row for one car. So if we take number of records, we'll get to know how many cars we are talking about. If the number of records is 10, it means we are talking about 10 separate different cars. So we take number of doors, we hold down the control key, we select number of records, we go to show me, and we choose this pie chart. So Tableau is taking some time. It has drawn the pie chart on screen. This pie chart is like really, really small. So you can bump up the size if you want to. Go to the size section, click once, and you can use the slider to make your pie chart bigger in size. It's looking a bit strange because, so this is a new feature in Tableau. Actually, I've also installed Tableau 10 recently. They released it last week. So let me see, how can we put it in center of the screen? It's crazy. I need to probably increase the size of my canvas. Okay. So probably I need to reduce the size a little bit. Here we go. So do not increase the size a lot. Then this is problem associated with version 10. In version 9 and older version, it was relatively easy to increase the size of your pie chart. So make sure you're not making your pie chart extremely big. Keep it relatively manageable, and then increase the size of your canvas. That way you are not going to face that odd outcome which I just did. Okay. So keep it of a standard size and fit it on the entire view. All right, so quick question. Were you able to create the following pie chart? Are you able to see this pie with two different sections, one for car with 4 doors, one for car with 2 doors? Okay. All right, so now we are going to learn something really important, okay, which we haven't learned so far. So step number 1, we want to show how many cars we are talking about here. Okay, so we can always hover our mouse and we can see this section of the pie is referring to car with 2 doors, and we have 81 such cars. This section of the pie, car with 4 doors, we have 114 such cars. What if I want to show these numbers right on the screen itself? So we'll take number of records and we'll drop it on the label section. That's one way. Another way, if I undo this, another way is click on label and choose show mark label. This is a non-preferred way. So I'm just going to uncheck this one. I'm not going to go with this option. I'll take number of records, throw it on the label section. So this section of the pie, 81 cars. This section of the pie, 114 cars. Now I have to refer back to the color legends here. Blue section is for 4 cars, 4 doors. So this is blue section. It is for number of doors, which is 4. Orange section, number of doors 2. What if I want to not refer to this color legend? I want to show that right on the screen itself. So I'll take number of doors, throw it on the label. So this section, 2 doors, 81 cars. 4 doors, 114 such cars are there. This is something which we learned yesterday. Now we are going to enhance the labels. a bit further. Done? Okay, thanks for confirming that. Now I want to convert these figures. I do not want to look at absolute numbers here. I want to see in terms of percentage value, how many cars are having 2 doors. In terms of percentage value, how many cars are having 4 doors. So it's very simple in Tableau to do that. This number right here is referring to the number of cars, and we want to convert this one into percentage value. So we want to change the label, this label, it is referring to number of records. So we right click here. We want to convert this into percentage. So we right click, we go to quick table calculation, and we choose this option, percentage of total. Not percentage difference, but percentage of total. Make sure you select this option, percentage of total. Many people accidentally they choose percentage difference and get wrong results. So percentage of total is what we are going to choose. So 41.54% cars out of the, let's say if we have 100 cars, 41.54% have 2 doors. 58.46%, majority of cars have 4 doors. So please convert your numbers into percentage value and confirm to me once you are able to see the same numbers which I have on screen. All right, thank you for the confirmation. So I'm just assuming that everyone was able to get the percentage figures. Now, if you want to format these percentage figures and remove the number of places after decimal, want to round them off. So this is the section. See, this is called as table calculation. What we just performed was a table-based calculation, a quick calculation. And if you perform a calculation, a quick calculation, there'll be a triangular symbol. See this triangular symbol? See this one? Whenever I'm bringing my mouse, the symbol is just fading away. But this triangular symbol, it is referring to this field. It is pointing out that this particular field is actually based on a calculation. A calculation has been performed here. Okay, so we were able to identify that this component, by comparing the icon, this component is responsible for the percentage value, and this is what we need to format and reduce the number of decimal places. So we right click and format, go to number, choose percentage, and reduce number of decimal places. Maybe make it 0. So go to the percentage section, not custom numbers, not any other place, but percentage, and reduce the number of decimal places to 0. So 42% cars have 2 doors, 58% cars have 4 doors. In total, it's adding up to 100%. So Dinesh, could you please check if you have chosen in the quick table calculation, if you have chosen percentage of total? Let's say if by mistake, if you choose percentage difference, you'll get a wrong figure. So make sure you have chosen percentage of total. Could you confirm that, please? Okay, so is the problem still persisting? Should I, okay, for number of records? Okay, so let me make you the presenter, Dinesh, and you can share your screen with me, and I'll try to fix the problem. So here we go. I'm going to make you the presenter now. Okay, could you right click there? Yes. Go to quick table calculation, please. Percentage of total. Okay, that's perfect. All right, so what has happened here, I am telling you what actually has happened is, this problem is happening because of formatting issues. Right click and choose format on that label. Okay, go to that number section in the default area, number section. All right, here we have chosen number custom. We need to choose percentage. So basically what has happened is percentage values are, it's like decimal places. So Tableau is actually showing you 0 and 1. What it meant to show you was 0.42 and 0 point something, whatever. So you need to choose percentage value. So your calculation, all the steps you took was absolutely correct. It was just a formatting issue. Okay. So I'm going to take back the screen control now. Share my screen. Just a quick check. Were all of us able to tweak our label to show percentage value? All right, thank you for confirming that. Now, let's modify this label further. Okay, I want to show here that, okay, we have 42% cars which have 2 doors, but how about the absolute number? How many cars in total are we talking about in terms of absolute numbers? So you can drag number of records again and throw it on the label section. Drop it twice. So now we have percentage value, the identifier, and the absolute value, all three of them. And now we have, if you compare the icon, we have 3 labels here. One with a triangular symbol, which is some number of records. We have another some number of records without the triangular symbol, which means these are absolute number of records. And then this one, a calculation has been performed, which shows percentage value. And then we have number of doors, which is 2 door or 4 door. If you want to change their sequence, you can just drag and drop values from one place to another. If you want to show percentage, let's say at the bottom, you can keep percentage, this triangular symbol at the bottom, then the number, and then number of doors at the top. So you can customize the labels as much as you want to. On top of that, if you want to further customize your labels, go to this label box, something which we discussed yesterday. Go to the label box, go to this text area, this triple dot, click here on this triple dot, and then you can type in your custom text like door equal to number of cars, or maybe if you do not want to type it this way, maybe just show the percentage value in under bracket. You can do that. So what have I done here? The first line of my label will show number of doors with this constant value. The second line will show number of cars in absolute term, and then a bracket symbol. See, these are constant values. They will appear as is. And then within that, we have this percentage value. I apply. See, number of doors is equal to 2. We have 81 such cars here, which are 42% of the total number of cars. Number of doors, if there are 4 doors, we have 114 such cars. Out of 100%, 58% cars have 4 doors. So we can really customize our labels as much as we want in Tableau. So I'm going to just remove the visualization and I will start from scratch. So I want to compare number of doors. You know, how many cars have 2 doors, how many cars have 4 doors. So I select number of doors and number of records. Okay, I want to look at what percentage of cars have 2 doors, what percentage of cars have 4 doors. Hold down the control key, select both the variables, go to show me and choose this pie chart option. Then increase the size, make it fit the entire view, so you'll have a bigger pie chart. If you want to further bump up the size, you can do that a little bit. And then I want to show the labels here. I do not want to refer to this size legend and this color legend. I do not want to hover my mouse. I want to print this pie chart. So I want to show labels here. So let's take number of doors, drop it in the label section. Now Tableau is telling us this section of the pie is for 4 doors, this section of the pie is for 2 doors. Take number of records, throw it in the label section. Tableau will tell us we have 81 such cars here. We have 114 such cars in the blue section. We want to convert this into percentage value. Right click on this label which is responsible for this number. This is the label, some number of records. Right click, go to quick table calculation, choose percentage of total. 41.54% car, 2 doors. 58.46% cars, 4 doors. You want to format this, right click and format. Click on this drop down, set them as percentage with no decimal places. Rounded up numbers, rounded up percentage values, 42% cars in the orange section. You want to show absolute numbers as well here, you can do that. Drag number of record, throw it in the label section. Now we have car identifier, percentage value, and the absolute number. You want to format this label a little bit more, go to the label section, click on this triple dot, modify it as much as you want to. You can say number of doors equal to, and then a calculated value, which is number of doors. Anything which is appearing in this triangular bracket is going to be computed. Anything out of the bracket will be considered as constant value and will be displayed as is. Okay. Now this percentage value, you want to show it as is, and then followed by that you want to say ABS val, and then you want to show the absolute value. So I hit the delete button, this thing will come up. So now the text which I will get is number of doors is equal to some number, and then some percentage value, and then ABS value something. Apply this. Number of doors 4, 58%, absolute value 114. It's not looking very neat, so I will make use of brackets. So instead of ABS value, I will give a bracket symbol here, and then I will close that bracket. So some number of records will come within this bracket. These brackets are nothing but constant values. Hit OK. Number of doors 4, 58%, 114. This is how we can customize our labels. Quick check. Were you able to get it this time? All the labeling options. So let's move on. Would you try the following quiz? Could you try to create this pie chart? Show me, out of all the cars we have, how many have diesel-based engine, how many have petrol-based engine, and also please format the labels as per the screen which I have created, the chart which I have created. All right. So now I think we are in good shape to proceed further with our discussion. Our next topic for today is, just one second. Our next topic for the day are line charts. So what are line charts? Line charts is, as the name suggests, we use a line to connect a series of data points together, and it will help us identify trend in the data. Mostly line charts are associated with time related data. If you want to trend your data over a period of time, see how the data has been changing with respect to time, in that case we use a line chart. But having said that, people do use line chart in other situations also, even when they do not have a time related data. Even in that case they use line chart, and it works well. So how a line chart looks like, here is an example. Let's say we are trying to learn facts about dogs, and each day we are performing a short test and seeing how good we are getting. So day 1 we were able to guess 3 facts correctly, day 2 4 facts, day 3 12 facts, day 4 15 facts. We plot that using a line graph, day 1, day 2, day 3, day 4, and we see that we are getting better at guessing the facts about dogs. Okay, so this is how a line chart will help us identify trends in data. If things are moving in an upward direction, or things are moving in a downward direction, or things have changed since a past period of time. It was moving earlier upwards and then it has all of a sudden started moving downwards. Mostly line charts are used with time component. So let's try to create some line charts. I have uploaded another file on the share folder, which is this ts_wide_male female birth rate. So could you all please download this file and open it on your machine? Let me explain the kind of data contained in this file. All right, so once you are able to download this file and open it onto your machine, please ping me and confirm to me so that I can explain the data to you. Done? Okay. So the data is relatively very simple. This is called as a time series data, something which we are going to learn in greater details in one of our upcoming sessions. Okay, so here we have month-on-month information about male birth and female birth which has taken place in a particular city. Okay, So average number of male children which were born, average number of female children which were born in that city for a particular month, January 1946, February 1946, so on and so forth. So this is our data which we are going to utilize to create line charts. So let's open up Tableau and let's import this data within Tableau. So step number one, I've initiated and now I'm looking at start screen. I connect to this Excel file. TS_wide male female birth rate. I hit open. I preview the data a little bit on the start screen, this data screen. Now we are looking at a different kind of data field, which is this calendar field, which is time related data, date time data. Okay. So in Tableau, we have multiple different kind of variables which can exist. We can have a numeric variable, we can have a string variable, we can have a date variable, we can have a geospatial variable, and we can have a Boolean kind of variable as well, true false kind of variable. Okay. And what else can we have? I think I've mentioned everything, right? Is there something which I'm missing out? So Shilpa, you had this question, right? Start of the session, you asked this question. Were you referring to these kind of data types? Okay. So these are some common data types. I do not exactly remember the number of data types as such, but the common ones are string, numeric, and we have date, and we have geospatial, we have Boolean, and I don't exactly recall if there is another data type available. We have this data, we have previewed the data, we have month-on-month information of male and female birth. We go to sheet 1 and now we are ready to create our line chart. Now based on your operating system settings, your Tableau installation, your Tableau instance may import this data wrongly. Okay, at times what happens is if you have like a your operating system settings is as per India, in that case Tableau may sort of think of this particular column, this date column is in month, is in day, this is in month, day format. Okay, so month will appear first and then the date will appear. But based on operating system settings, Excel may interpret this in a wrong manner. So just make sure that you are rectifying this error if that's the case with you. So this is a operating system setting which you need to change. Okay. So now we are going to create our line chart. Let's try to visualize the trend of male birth, whether male birth has been increasing or decreasing or it has been stable over a period of time. So let's select month and let's select male birth by holding down the control key. Let's go to show me and select. We have for line charts, we have multiple different options. We have continuous line and we have discrete line and we have one here which is dual line. Dual line is right now not active. So we'll just go for continuous line. Make sure you're going for continuous line. Do not select discrete line, please. Please make sure you're selecting continuous line. As soon as you select continuous line, the chart will be created on screen. This is a line graph showcasing year-on-year trend of how male birth has been increasing. So there has been a slight dip in male birth and then eventually it has increased a little bit. Okay, now this is year-on-year information of male birth. What if you want to also see female birth information here? You can do that. You can just drag female birth and drop it right here next to male birth. So we'll have now two charts. The first chart is showing male birth. The second chart is showing female birth. As you can see from the axis, male birth and excuse me, male birth and female birth. Simple step, all you have to do is drag female birth and drop it next to male birth. So essentially what are we telling Tableau by doing this? Create two rows. In the first row, show male birth. In the second row, show female birth. Now by default, what happens is when you create a line chart, not a line chart exactly, but when you use a date field in Tableau visualization, by default, Tableau is going to start with year. It's going to aggregate your information at an yearly level, annual level. By default, it will do that. Every time you're going to use a date field. Let's say I want to look at this information on a month-on-month basis, or maybe on a quarter-on-quarter basis. So you can click on this drop down, and you can see we have year, quarter, month, day, year, quarter, month, week number, day. So we have year appearing twice, we have quarter appearing twice, we have month appearing twice, day appearing twice. Why are they appearing twice? These are discrete quarters. These are continuous quarters. These are discrete month, continuous month. If you select discrete month, then Tableau will look at each month of each year. January 1949, January 1950, January 1951. It's going to add up all those numbers. All January numbers will be added and you will be shown 1 point for 1 month. Okay, so January, February, March. Here, this number is all children born in January, all female children born in February, all female children born in March. And this is not what we wanted. What I wanted was month-on-month trend. So basically, I wanted this continuous month thing. If you select this continuous month, then January 1946, January 1947, January 1948, all of them will be separated out. So you will be able to see month-on-month trend, both for male birth rate and also for female birth rate. So I'll give you all some time. Please try to create these two charts, male birth and female birth, appearing on top of each other, and convert them to show it on a month-on-month basis. All right, I've got confirmation from Dinesh. Who else was able to get it done? Please do ping me and confirm to me so we can proceed further. Okay, I've got confirmation from Virendra, Mr. Chaudhary, Vineet, Shilpa. Naveen, how about you? Done? Okay. Anand? All right. So in case you do not have Excel, are you not able to import it, Anand, within Tableau? This file, are you not able to download this within Tableau? Oh, sorry to hear that. Let me do this. I'm going to convert this file into CSV format. And just in case, Anand, if you do not have Excel, you can always install this particular software. This one here is a very good alternative to MS Office. This is free of cost. This way you will be able to open up Excel file and create pivot tables, everything. Okay. Anand, were you able to get this one? LibreOffice, I think, is what we say it. If you want to, you can install this. Okay. In the meanwhile, what I'll do is I'm going to save this file as CSV for your benefit, and I'm going to share it with you. Okay, so on the share folder, I'm going to paste this in a CSV format. Here we go. So Anand, just pick up this CSV file. It contains the same data and try to create your line chart using the CSV file. So Virendra, we are going to discuss about discrete versus continuous. One difference I showed to you already. Okay, the difference is basically if you go for option, this one, your month will be considered as one single category, and then across years it will be added up. Okay, similarly you can go from choose a quarterly, on a quarterly basis. If you choose discrete chart, then see we have 4 quarters in a year. What Tableau is doing, it's looking at quarter one of every year. We have data for how many different years here? We have data for from 1946, we have data till 1959. That's like more than 10 years of data. So Tableau is just accumulating data for each year for first quarter, and then it's adding up together. Versus if you choose the continuous option, Tableau will look at first quarter of first year, second quarter of first year, third quarter of first year, fourth quarter of first year. Then it will go to second year, first quarter of second year, second quarter of second year, third quarter of second year, like that. So this is continuous. If you go for discrete, Tableau is just going to show you 4 different quarters and will club data of all the years together into that. Does that make sense? So mostly for analysis purpose, we never use discrete option. We always use the continuous option, because now we are able to, if we use continuous option, only then we'll be able to see the trend associated with the data. Naveen, did that answer your question? Okay, perfect. So let's move ahead. So we now are looking at, let's keep it as month-on-month basis, month-on-month trend of male birth versus female birth. Something special has happened here. What has happened exactly is, there are scenarios, Naveen, to answer your question, there are scenarios where we can use discrete also. You'll actually look into a particular situation. In one of our future sessions, we are going to use a case where discrete is more powerful. Okay, now looking at this chart, we have male birth, we have female birth. There is something special which has happened when we have kept these 2 categories here, 2 continuous numeric variable. What has happened here is, if you look into the marks section, we now have 3 different layers of marks. We have a mark for all, we have a mark for male birth rate, and we have 1 layer for female birth rate. You make any change in the all layer, let's say I change the color, both the charts will be impacted. You select the layer for male birth, change the color, only the color for male birth will get impacted. You select the layer for female birth, change the color or the size or anything else for that matter, only the female birth trend will be impacted. So if you want to have like 2 different colors for each of the trend line, you can do that through these layers. So at times these layers will become active, and you can sort of like customize your chart using one of a specific layer. So please try to provide different colors, one separate color for male birth, another separate color for female birth. So that should be easy. I'm assuming everyone will be able to get it done. Now, what if we want to show both of these charts together? We have 2 separate charts right now, one appearing on the first row, another appearing on the bottom row. What if we want to combine them together, show them in one single view? We can do that. Click on this drop down or right click on female birth. Make sure you are clicking on the the last category. If you right click on male birth, it's not going to work. Right click on female birth. There'll be an option for dual axis. Choose this dual axis option. Let me show you. Again, if you right click on male birth, there is no option of dual axis here. Okay. If you put male birth in the second position, so female birth will show up on the first position, male birth will show up on the second position. If you do that, right click on female birth, there's no dual axis option. It's always available on the secondary value, one value which is appearing last. So right click and choose this dual axis option. If you do that, both the line charts will now converge into one single view. Your layers are still intact, so you can provide different colors based on your choice. This male birth orange color, I do not like that. I want to change it probably to, I'm sorry, yeah, male birth I want to change it to blue, and female birth I want to change it to pink, let's say. Apply this change, a male birth versus female birth in one single view. This is dual axis chart. If you want to change the color, Shilpa, were you able to convert this into dual axis? Okay, so go to this option, or maybe if you want, you can go to any of the option, click on the color section and choose this option, edit color. Now you will have female birth and male birth. You want to change the color for female birth trend line, select it and choose any color of your choice. Want to change the color for male birth, select it, choose any color of your choice. Apply the change and here it is. Please try that out, Shilpa, and let me know if you are able to get it done. Oh, so Shilpa, let's do this. I'm going to make you the presenter, and that way you can share your screen and I can try to help you step by step. So let me pass on the ball to you. Here we go. Okay, so there, what has happened here is this measure value, which says male birth, measure name has appeared in the rows section. So just remove that, please. Please remove measure name from all the places. I think that should, yeah. And also remove measure value from the color section. So there's this color section. If you close that box, please. Yes, remove that. Okay, now you can edit the colors. Oh, that's strange. All right, it doesn't work. Let me request you, Shilpa, I'm going to request you for keyboard and mouse control. If you can just hand over the keyboard and mouse control to me for a second. I'm going to send the request now. Okay, thank you. Let's see if I can move the mouse around a little bit. Here we have, okay. From filters also we are going to remove measure name. Okay, this is kind of strange because you are getting different option, a little bit of different option from what I was getting. But essentially we are able to change the color, as you can see. But have we not converted this into dual axis? I think we have done that. So let's create it from scratch. Very quickly I'm going to do that. Let's see if we get that option back again. So I'm going to take month and female birth and male birth, all three categories. I'll go to show me area, select this line chart and convert your information to month information. And then I'm going to join these two charts together using the dual axis option. Okay, now if I go to the color section, I'm getting this edit color. Maybe some steps which we have taken that change the behavior of it, but essentially we are getting that coloring option back again. I hope I was able to answer your question, Shilpa. All right, thank you. So I'm going to take back the presenter control now, make myself the presenter. And now we are going to interpret the charts. Okay, Anand, I just saw your comment. So CSV data which you are getting, I I think the problem is happening in the date part, okay? Because CSV is independent of the format. So what is happening is CSV is looking at this data. It's saying, okay, we have a 12/1/1959. Is your keyboard setting as per India region? So if you on this area, are you able to look at first the date, then the month? Oh, it's as per US. Let's do this, Anand. After this session is over, I'm going to make you the presenter and we can sort of like connect one-on-one and I can try to help you out. Fair enough? All right. So let's continue our discussion on the line chart. In the meanwhile, Anand, you can just follow the my screen and later on you can work on this quiz offline. Okay, so let's try to interpret this chart. What trends are we looking at here? So start of the society, let's assume that only children were born and nobody died, and this was the start of the civilization. So one can assume that initially we had the male birth rate was higher. Okay, the male birth rate was higher and the female birth rate lower. But now male birth rate and female birth rate are almost equal to each other. Fair enough, people will be able to interpret that by looking at this chart. Okay, initially male birth rate was higher, female birth rate was lower. Now they are equal. Is that a correct interpretation, or is there a problem with that interpretation? Have I made a correct conclusion, or have I made a mistake? Okay, so if you just look at this data from a trend perspective, the interpretation is correct. But if you look at the axis, female birth rate versus male birth rate, their axes are different. This chart is misleading. Okay, the axes are not equal. So let's right click on one of the axes and let's choose this option, synchronize axis. If we synchronize the axis, now both the axes will be equal to each other and our interpretation will change drastically. So our initial interpretation that male birth rate was higher than female birth rate, that was accurate. But our second interpretation, both birth rates are equal now, that was wrong. Female birth rate has surpassed male birth rate. In around 1955, female birth rate actually took over male birth rate and now we have more number of female children being born. Now this is correct interpretation. Do you all agree? So please try to synchronize your axis and let me know once you are able to do so. Step is simple. You just need to right click and choose this option, synchronize axis. Okay. Now let's interpret this chart again. Somebody may be tempted to think, okay, we had less number of female earlier, but now we have more number of female. Considering this was start of the society and these were the first children being born and nobody died and they're just adding up to the population, we have more number of female as compared to number of male. Now that interpretation also is wrong. Why? Because this is just month on month number. These are not cumulative numbers, are not adding up. Historical data is not being added up here. These are just month on month number. This month we had more number of male children and less number of female children. This month we had more number of female children and less number of male children. Okay, it's just month on month comparison. How they have added up historically is not being shown. Can we do that in Tableau? Yes. Again, we'll make use of those quick calculation. So right click on female birth, go to quick table calculation and choose this option, running total. Choose this option, running total. This is cumulative growth in female numbers. Do the same for male birth, right click, go to quick table calculation and choose running total. This is how the number of males have been increasing in society. This is how number of females have been increasing. Still, number of females is less than number of male because initially the female birth rate was less and then it eventually caught up somewhere around 1955 and now the gap has been closing, the gender ratio has been balancing out, but still we have fewer number of females as compared to number of male. So I'll repeat the step. Step is simple. If you want to perform a cumulative calculation, right click, go to quick table calculation. This is a very useful option. There are a variety of calculation options available. You can experiment with them later on. Right now, we are going to go to quick table calculation and choose running total. I want to look at running total. As new data comes in, it will get added up to the total. So running total of female birth rate. Similarly, I want to calculate running total of male birth rate. And I'm assuming all of us will be able to do it. The steps are really simple. Okay. Now, final point which I want to discuss is, let's say you want to highlight a certain point in time. So there was a change in trend for female birth rate. Initially it was lower and then it picked up in 1955. Let's say you want to highlight this point. This is a historical point. Maybe the perception of society changed here. You want to highlight this, you can right click and you can annotate this point. So you go here, annotate this point, and you can type in your comment if you want to. Changing point in female birth rate. You want to type in this comment and highlight this point, you can do that using annotations. You can drag and place it anywhere you want to. Okay. So this point, Tableau is highlighting this changing point in female birth rate. How to annotate? Just right click any point you want to annotate and right click, go to annotate and choose this option. This way you can annotate a point. You can also annotate a mark or an area, which we'll look into later on. But right now we are just going to annotate this particular point. And you can format it, make it look sort of like bolder and darker and all those things you can do. So here we have like a formatting option available, right? Go to the formatting option and you can sort of like play around with the formatting. Shading is, maybe choose a dark black color. This doesn't look good. How to change this arrow? Earlier this arrow used to be like darker in shade. Okay, I'll probably try to find out a way through which you can make this arrow darker. Oh, here it is, I think. Okay, if you want to sort of like refer to the point, you can do that. Okay, so were you able to annotate this point, this changing point in female birth rate? In case if anyone has any question, doubts, please do let me know. So what all things we have learned? In line charts, we have learned about multiple line charts, how we can create multiple line charts, dual axis line chart, and running total with annotation. So we have learned all of them. Now let me share with you one small tip, which is not part of our curriculum, but based on my experience, I want to share this particular tip with you. Importance of data structure. A data structure is such an important thing. It plays such a vital part in Tableau analysis, and which people constantly undermine. Okay, here we actually did a lot of hard work in getting to this point. There's an easier data structure. If you just structure your data a bit differently, you will be able to generate all of these charts, which I showed here, all of these charts. You'll be able to create them much more easily. Okay, so this is that data format. TS_long versus TS_wide. So how does a long format looks like? This is the long format. Same information, same numbers. But what I have done here is I have put a classifier here, an identifier for gender. So January 1946, male birth was this. 1946, female birth was 18. So each month will be repeated twice. And then we'll have a category for male and female, and then their numbers. If you compare it with the previous numbers, it will be exactly this, similar. So January 1946, 27 male, 18 female. January 1946, 27 male, 18 female. February 1946, 2418. February 1946, 2418. Exactly same number. Let me import this in Tableau, and you can do work on this along with me. I'm going to share long data format. I have posted it on Google Share Drive now. You can download it. TS_long male female birth rate. If your data format is in this particular format, long format, let's open up a new instance of Tableau. I want to import this data. How can I import it into Tableau? Always make sure you are right clicking on your Tableau and opening up a new Tableau file. If you have not pinned your Tableau to your taskbar, you can go to Start menu and start Tableau once again. That way, you will be working on a new instance of Tableau. So do not import data within the same file. Otherwise, you will end up blending it, which may lead to some problem later on. So it's better to open up a new instance. Once we learn data blending, then you can work with multiple data set in the same file. Okay, so now I'm going to import the long data format. This one, the second format, where we have only 3 columns. And we have one column which identifies male and female birth rate. 1 month is being repeated twice. Okay, so this is that data format, and I'm going to import it within Tableau. Now, look at the magic. Just because of the data format, how we are going to get benefited. Take month, take birth, month and birth, go to show me, choose continuous line graph. This is yearly information. You can focus on my screen for the time being, and I'll give you enough time to practice it on your own. So go to this section and convert yearly information into monthly information. This is total growth, total birth rate, both including male and female. If you want the same effect in the initial analysis which we were doing, you were supposed to create, in this case, if you want both male and female birth rate together, combined, total birth rate, then you need a calculated field. Here we do not need any calculated field. What if you want to break this view apart into female birth rate and male birth rate? We have total birth rate. We are working on long data format now. Take gender, drop it in the color section. Male birth rate, female birth rate. No need for dual axis at all. What if you want those 2 separate line charts? Take gender, drop it here. 2 separate line charts. Want to color code it? One for different color for male, different color for female. Take gender, throw it in the color. Steps are different now. Effects are same. This one I think is easier. Okay, no need to remember a dual axis chart at all. Want to combine them together? You can do that. Just take gender, drop it in the color section. Okay, you want to convert them into cumulative? No need to do it twice. Only one calculation is required. Okay, running total, cumulative. See, it's so easy. Saves so much of time. Just consider we have 10 different categories, not only male and female, but we have Indian, USA, Australia, all these different nations. Where you supposed to, would you like to do this calculation 10 times, or rather restructure your data in long format and do it just once? Which format do you like more? So, question from Vinith here, and that's a very relevant question. Do Tableau has this option of converting wide to long format? No, Tableau doesn't. This is one of serious limitations of Tableau, and probably in some, newer version of Tableau, this might be taken care of. But for the time being, you have to do it on your own. So converting from wide to long format might not always be useful. For some statistical analysis, especially while creating scatter plots and all, you do require that wide format. So at times wide format also might be useful. So if you want to create a scatter plot here with a long format, it might be difficult. Creating a scatter plot with wide format is more easy. Okay. So, but in general, for Tableau based visualization, long format generally in 90% of cases, long format is better. It will save you a lot of calculation steps, a lot of manual work. So it really is up to you, and it comes with experience. Once you start working with Tableau, you'll realize what kind of format do you want. Data restructuring, major formatting in data, major restructuring of data has to be done outside of Tableau. And that's where, if you have knowledge of some ETL tools or good knowledge of Excel or R or some data manipulation tool, that's going to benefit you. But with the trend Tableau has adopted, I'm pretty sure in next few versions Tableau is going to come up with this thing. And in fact, I know there is a macro available which Tableau has published. There's an Excel macro which you can download and you can use it for data restructuring. But it works on not on a large volume of data, considering it's just an Excel macro. So if you have millions of rows of data, it's of no use. But did you like the wide format or the long format? In this particular case, do you agree that long format is much more beneficial? Yep. So please try to take this long format and quickly, if you can, try to create all these three charts. Multiple line chart, dual axis, both the lines together, and then running total. Could you take the long format and try to do this on your own very quickly? And please let me know if you need any help. Yeah, Dinesh, yeah, from a learning perspective, typically I took wide format only for that reason, because I wanted to discuss about dual axis. I want to discuss about these features. So if you are stuck with a wide format, then how to work with it. So I deliberately chose that to facilitate our learning. So yeah, so it had its own benefits, of course. Let's go ahead and conclude our discussion for the day. Today we learned a lot of important things. Let's quickly recap. We learned about visual analysis, in particular, different kind of common visualization, scatter plot, histogram, bar graph, box plot, pie chart, line graph, and when to use what kind of visualization. So let me quickly ask you a few questions. I'm going to present to you certain scenarios. You need to type in your answer. Which kind of chart, which kind of visualization you are going to use based on the scenario I'm going to give you. Okay. I want to find the relationship between the sales which my company has generated versus the number of sales staff I have kept. Okay, in different regions of India. City number 1, I had 10 sales staff, sales was 100,000. Mumbai, 20 sales staff, sales was 1200. X number of X city, I had so many sales staff, this was my sales. So I want to find the relationship between number of sales staffs and the total sales I've generated. Which chart should I use? And the sales staff can be anything. It can be 12, 14, 19, 25, 39. It can be anything. Sales can be anything as well. So both of them are ratio values. So we need a scatter plot. Are you getting the picture? Yep, scatter plot is what we need. Okay, how about this? People are driving on a highway. I want to see the speed distribution. Are most of the people driving at very fast speed? Are most of the people driving at very slow speed? Or is it like most of the people are driving somewhere in between? Very few people are extremely fast, very few extremely slow. Speed distribution. Histogram is what we need. Yep. I want to see the speed distribution of, let's say, people who are driving on a highway versus people who are driving on city roads. In city road, do people drive fast or slow, or in highway, do they drive fast or slow? I want to compare the distribution between these two scenarios, city road versus highway. Which graph should I use? Box and whisker is what I should use, right? Box and whisker plot. I want to check the distribution of speed across two different situations, city and highway. Okay, so box plot. Does that make sense? Everyone agrees? Yep. Okay. Now I want to see, out of the total sales I have generated within last 1 year, my company is selling soaps and toothpaste. So how much sales came from soap? What percentage of sales came from soap versus what percentage of sales came from toothpaste out of the 100% sales? So in this case, I would say pie chart is a good choice. But if I want to compare the sales in absolute terms, I do not want to look at sales as 100%, but I just want to compare them side by side. Toothpaste versus soap. How many dollars worth of sales I've done for toothpaste versus how many dollars worth of sales I've done for soaps. In that case, not percentage, but absolute dollar values. I want to compare them. Bar charts. Okay. And of course, in the field of visualizations, you can use alternate techniques. It's not that, if you show somebody a pie chart and display the labels there, they'll get some idea, but a bar chart will do the job better in this case versus breaking up 100%. Even bar chart will do the job, but a pie chart I think will be better suited. So you can try to mix and match the graphs also. So we can use graphs interchangeably. That's fine, but best suited method is as per the one which I described to you, and you can follow reference books. They will refer the same thing. They will sort of like recommend you the same thing what I told you. So you should remember, if you have two ratio data, you want to find relationship between them, we use a scatter plot. You have one ratio data, you want to find its distribution, we use a histogram. You have categorical data, nominal data, you want to compare categories together, maybe by their count or maybe by some other numeric measure, we can use a bar graph. You want to compare the spread, the distribution of two, one continuous numeric variable, one ratio variable across two different categories, point-to-point comparison if you want to do. We use box plot, and especially if you want to find outliers. In that case, box plot is absolute must. And then pie charts if you want to break apart your 100% into contributing components. Line charts, if you have a time related data, you want to trend it over a period of time, things are going up or going down, we use a line chart. Okay, so this was our learning for the day. Did you find the discussion informative? Did you learn something which you were not aware of? Not from perspective of Tableau, but from other general perspective, things which we discussed today. Yeah, glad to hear that. So for next week, our agenda will be advanced visualization. So next week, we are going to learn about tree maps, and we are going to learn about bubble charts. We are going to learn about Gantt charts. We are going to learn about stacked bar plots and how to tweak them. In fact, we are going to actually create some charts which are not available in Tableau by default. So we are going to use our knowledge which we acquired today. We are going to use that knowledge to create those charts which are not available in Tableau at all. So for example, 100% stacked bar plot. It's not available in Tableau, but we are going to create that next week. Sounds interesting, Vineet? Okay, so looking forward to meeting you all next week. If anyone has any questions, you can stay back. Those of you who do not have any question, I wish you a great week ahead and hope to see you next weekend. Please do take out some time to fill out the survey which you will be presented with the session. Please do take out, it will be only a fraction of a minute which you have to spend there, but it's like really important for me. So please do that. Thank you. Thank you, everyone. So Dinesh, you can please stay back, and Anand, you can stay back. Let's discuss the question which you had. Anyone else who has any questions can please feel free to ping me. Okay, so Dinesh, let me show you how we can create multiple line charts. Are you talking about the long data format or the wide data format here, Dinesh? Okay, the long data format. So with the long data format, if you want to look at the overall birth rate, select month and birth, go to show me, create a line graph, and then convert this probably into continuous month. So month on month, both male and female children born is shown here to the overall birth rate. And you want to break this apart by male birth rate and female birth rate, two separate line charts. Take gender, drop it here. So essentially, what are you telling Tableau? You're saying create two rows, one for each gender, and show me birth rate. So female birth rate, male birth rate. If you do not want that, If you want both the lines to appear on the same canvas, drag gender, throw it on color. So Tableau is going to create two lines, one for each gender, and it will color them separately. You want to perform that cumulative total calculation, go to quick table calculation and choose the running total option. Did that answer your question, Dinesh? Okay. See you next week, Dinesh. Have a great week ahead. Bye-bye. All right. So, Anand, let's discuss your question. Can I make you a presenter and let's see what kind of problem you're having with your CSV file?
Yeah, sure.
All right. I've unmuted you so you can speak out and I'll be able to hear you. So here we are. I'm just passing on the ball to you now. Okay, so I can see your screen. Could you please open up your CSV file?
Yeah, this one.
Okay, here it is. Please take, can I request you for keyboard and mouse control? Let me just do that
Yeah,
quickly.
yeah, sure.
Okay, now let me see if I can move your mouse around. Here we are. Okay, so now what I'm going to do is I'll take month and I'll hold down the control key and I'm going to select female birth rate. And let's try to, oh, okay. So there's a problem which has happened here. Month is supposed to be a date field. Now Tableau was not able to identify that. Could you please open up your CSV file, Anand?
Mm, what this one is? I think you have the control, I guess. So minimize.
Uh, Now you can move the mouse around. I've just left it for you to access.
Okay.
So if you're not able to find the file, you can go to the shared folder once again,
No,
and you
it,
can
it is.
download. Oh, it is right here.
Yes.
Okay. No
Okay.
problem. What you can do is just right click on the CSV file.
Yeah.
Oh, here it is. Okay, so we have month and
So probably it's fine. I understand that issue with this data.
yep.
I will either I will
Yeah,
uh,
so if you install that LibreOffice, I think that's going to solve the problem. So just uninstall Microsoft Office because the installation
uh,
it seems to be corrupted.
I
So
do
just
not have
uninstall.
the
Yeah.
Microsoft Office.
Oh, okay.
So I will try
Okay. Yeah.
to use some a trial version and then I will fix
Sure.
it.
Sure. Yeah,
Thanks. Yeah.
and you can
They will.
you can just use that LibreOffice, and if it doesn't work, next weekend, probably we can connect together, and I can show you a way through which you can use Google Docs. So Google Docs is available free of cost, but your documents needs to be uploaded, on Google. So I can show you a way through which you can keep your file on Google Doc and connect through Tableau Public. So there are a lot of possibilities. So no need to worry. See if you can get this Office installation fixed. If it doesn't work, we'll fix this problem next weekend. Fair enough?
Yeah, yeah. So I have one question if you don't mind. So,
Sure, sure. Please go ahead.
yeah, for this uh, Tableau, right? Along with there are like a requirement in the job. Many of them asking the expertise in the SQL. Do we use it really SQL?
See, I tell you, SQL is not required for Tableau. Okay, it's not required. But let's say if the company, the
Uh-huh.
data for that company is stored in a database. Okay,
Uh-huh.
so it depends from company to company. Let's say company is using IBM DB2 to store its data. So in that case, you have two options. You join the team and they will give you access to that DB2 tables, and you can extract your data in CSV format or Excel format, and then you can use the same method what we have been discussing so far. That will be some additional effort on your side. Let's say the data is very huge and the company requires you to make live connection to the databases. So any update which happens on the database will automatically reflect back in Tableau visualization. In those kind of cases, you do need at least some basic knowledge of SQL code. So basically SQL codes are pretty much automated these days. So you can use tools like Toad. Have you heard of Toad?
Yeah, Tor SQL developer and also I am familiar with. Even though SQL also I am familiar, but I'm not into it to doing regularly. So I lost it. If I was wondering that if it is required or
Oh,
not.
okay.
If it is required, I
Nah,
will.
it's not heavily required. You just need to have basic understanding of SQL. So if you are familiar with Toad and other such tools, you can use them to generate the SQL code, and then you can just copy and paste it and use it in Tableau. I'll show you in
Yeah,
one of the sessions. We are going to use such a scenario where we'll generate SQL code from another tool, copy and paste it in Tableau, and we'll use it straight away.
this course is basically Tableau development, right?
Yes.
Oh, okay, so okay,
Okay.
that's it.
So
I think. Uh,
yeah.
yeah, so if I put it 10 years of experience, do they ask like OBI, Cagnos, these are all also to be required for
No, not
surveying?
really required. Not really required, but it helps. Let's say if you have prior experience in some other BI tool. So Tableau
Uh-huh.
follows the same concepts, right? I mean, if you work with Cognos, Cognos also has drilling down capabilities. You can click on a particular section of your dashboard and you can drill down rest of the areas. Yeah, you can do that, right? So
Oh,
similar to
because
that, Tableau has, yeah.
in the job posting, they are all placing all these requirements. So I was wondering that if it is all required for going and attend interview.
No.
Uh,
So if you have some good knowledge of Tableau, see, it's like, if the major focus is on Tableau development, then they
uh-huh.
are just going to, it's like a good to have thing if you know Cognos or SQL. It's not that it's going to restrict you from doing your job. So what I would suggest is go ahead, attend a few interviews, maybe one or two of them. That
Oh,
will give you some
here
idea of, yeah.
I don't think so. Here it is tough to get interview call. Like, uh,
Uh-huh.
if I get it the one interview, I must have to clear it. It's a very slow process here that it takes months to get it.
Oh, okay.
Yeah. So
Okay.
in India, yeah, we get it. Like I worked in India as well. Okay, so in India we get it
Mm-hmm.
on the same day after we post a resume. But here, like, we must
Oh,
have some reference and then they
oh,
see all the LinkedIn profile and then see
okay.
so many factors and then only they call. For the getting call is tough. Or the remaining things okay we can
Mm,
do, but getting call
okay.
is not that easy. So if I get it
Oh,
one two calls, basically I will have to be
okay. Convert them.
fulfill their requirements. Otherwise it uh,
Okay.
is a tough
Okay.
task because I'm in a great trouble that my H1B is getting to expire and then my
Mm.
current company is not moving the next
Oh,
step, so I
oh,
will
okay.
have to be uh,
Mm.
get it very
Oh,
soon my job.
mm. I
So that's
understand.
why like
Yeah, that,
I was keep on the day first onwards I was keep on searching that the requirements and also what they required for the because I had like experience on this OPI. It's kind of OPI and all what I had that I have had a great experience on the administration part and all. Not I used to support to that BI guys, but now things are changed. So it's not the technology side. Moreover, moving Hadoop. So
okay.
if I can go to Hadoop, but it takes time, like to start it
Mm.
learning Java and then get into the job is tough thing. So this
Uh,
I feel that okay, it looks like to learn easy and then attending interviews it may helpful. get into in a time period,
Mm,
small time period.
great,
So
great. So
because
yeah.
as you're working, so it doesn't just they ask these things, but interviews and all they based out Tableau only.
Oh, okay, okay. So what we can do is, as I mentioned yesterday in our first session, I'm going to
Uh-huh.
take a like an interview session. So what kind of common questions you can encounter with respect to Tableau only, and of course there is like an ecosystem involved with Tableau. So we have SQL codes. If you're going to connect to a database, you have to deal with SQL codes to make further automation in your work. Let's say if you're working on a excuse me, there are other factors also. If you are going to publish your work onto Tableau server and you are going to host a particular website which has Tableau visualization, they may ask you to know JavaScript also. Now that's an extreme requirement, but that's very rare, but it may so happen. Okay, so what I will do is from a Tableau's perspective, all you have to do is after this entire course is over, just raise a ticket on Edureka support and ask them to conduct 1 hour session with me, and I can take you through common interview questions of Tableau, and I will keep doing that. So today I told you about identifying outliers. Now that's a very typical question which is asked very commonly in any analytical interview. So these kind of questions I'll keep highlighting, and plus we can have like a dedicated session for 1 hour where I can take you through different questions they ask commonly in Tableau based interview.
Thank you for watching the video. Feel free to comment your doubts and queries. Do subscribe to Edureka channel to learn more. Happy learning.